Hi, all. We'll just wait for a few more minutes. It's Sindhu also. We'll just wait. I think Rimple might not join us, so we'll wait for Sunita and Kopal if she's joining today. Two more minutes, we'll wait and then we'll start the class. So today's class will be talking about liquid soap making and an important ingredient for making liquid soap making will be is my voice and video clear for everyone? Let me know.
Yes, coming.
Okay.
Video is little blur, but voice is clear.
Video you can see?
Yes, you can see, but I think it is because of the background.
Okay. Otherwise, just give me one moment. I will just change my direction.
Hello, Maitri. We will be having that silicon mold class anytime.
I think so. So once Archana is ready, she's not like entire family has not been keeping well. So once she settles down a bit, probably like in a week or so, we'll surely be having it.
Okay, now is my video clear?
Yeah.
And audio?
Yes.
Okay. And I'll keep it like this only. So today's class is about liquid soap making. Today we will be covering all the theory of soap making, liquid soap making part. And an important aspect for making liquid soap making is you need to have potassium hydroxide. So without which you cannot make a liquid soap. So potassium hydroxide so will come like this. Let me change my it will come like this, like a pellets. Okay, this one I got it from a local laboratory, I mean, shop where they sell most of the lab chemicals and all. You will get it easily. Sodium hydroxide and potassium hydroxide are the most common chemicals that you can easily get in any of the even school suppliers, chemical shop, no? They will also have this potassium hydroxide, but get it from them, because why I'm saying this, they will have this everything written about the purity of your potassium hydroxide. Okay, so they will write assay, then how much of carbonate, chloride, sulfate. So potassium hydroxide will never ever be available as a pure 100% pure potassium hydroxide, because potassium hydroxide is highly hygroscopic, meaning it will immediately start attracting moisture to it in a pure form. So that is why they don't manufacture potassium hydroxide in the pure form. They always have some impurities attached with it. So we don't know, if you buy from other suppliers the flakes one, how much pure your potassium hydroxide is. Some will be 90%, some will be, see, this one which I'm having is 85% pure potassium hydroxide. So that is the reason why I told get the one from the chemical shop, because they will have everything mentioned in them. Okay, so okay, now we will start. I will share my screen and I will start with the presentation. Okay, are you able to see my screen? Let me know. Is the
Yes.
screen visible?
Yes.
Okay. Okay, let's start with liquid soap. So what is liquid soap? As I have already told, it is the soap which is made with using potassium hydroxide. But also there are another way of making liquid soap, that is called as a dual lye method, where they use both potassium hydroxide and sodium hydroxide to make a liquid soap. I know I told for cream soap or shaving soap or Beldi soap, for that only we use a dual lye soap. Even for making liquid soaps also we can use sodium and potassium hydroxide, but the percentage will differ for the cream soap and the liquid soap. Okay, with further slides I will explain more about it. So but the major thing about this liquid soap is that it doesn't need any curing, like how you have to cure your soaps with both CP and HP. Liquid soaps, they don't require any curing, but maybe people will call the soapers, they will use the word something called as sequestering. That means you make the liquid soap and keep and allow it to be dissolved in, in that dissolved state, you allow it to be like you allow it to be in that form for like say 3 to 4 weeks, or even or even longer it can be. But it is not necessary that you have to sequester your liquid soaps. You can start to use immediately once you made your soap paste and you have diluted the soap paste, then you can start to use immediately. And regarding next, we will have something topic about super fat. Unlike CP and HP soaps, where we usually want to superfat our soap, in liquid soap, we will try to avoid superfatting our soap as much as possible. Why? Because we want whatever potassium hydroxide is there in our soap to fully utilize all the oils in our lye that in our soap mixture that we have taken. Otherwise, what will happen if the potassium hydroxide does not neutralize the oils, then the soap paste or the liquid that you get after after making your soap, it will be very, very cloudy. You will not get a clear solution. So that is why we don't superfat our liquid soap. And does it require a preservative? It usually does not require a preservative, because the soap solution that we get, or the soap that we make out of this liquid soap, it is highly alkaline, meaning the pH is above 9 to 8 to 10, we can say. Yeah. So that is the reason. And most of the preservatives that we use in our skincare are somewhere, their uppermost limit is up to 6 only, the pH. So they are mostly acidic to neutral range only they have. They don't have much for alkaline, because most of the pathogens, that is the microbes, be it bacteria or fungi, they cannot tolerate such a very high pH. And even though there are some pathogens that can grow even in high pH, if we maintain a proper laboratory, if we like a proper GMP preparation, we make our soap and we store it in a proper way, we sanitize and we clean our area and we keep it clean, it can survive without a preservative also. I don't usually add any preservatives to the liquid soaps that I make. I have stopped making liquid soaps actually, but whatever I have made in my soaping experiments, I never used to add the preservative, because the preservative I did when I was not aware much about preservative and their pH range. I thought phenonip will be a good preservative, but when I read about the data, safety data, and about the technical details of that phenonip, I came to know that the pH range itself is not alkaline enough. So what is the point in adding to an alkaline soap? So that is why, but there is one preservative, Pseudocyde A, that can survive a pH of up to 12. That is the uppermost limit they have given in their in their data sheet. But I am not able to find that Pseudocyde A in any of the local suppliers that we have here. So if you get Pseudocyde A, yeah, you can add it if you are planning to sell your liquid soap. Otherwise, it does not require, as long as you maintain it in like a pump bottle and it is not frequently going to come into contact with the external water, or like no one is going to dip their hand into the liquid soap and then use it. So if you maintain such way of using the liquid soap, it does not require any preservative. Okay, then we will start to learn certain terminologies which we are going to use in our liquid soap making. So the first one, we will use the lye. Here we are using is potassium hydroxide, and next will come the method of making the liquid soap. So it can be made by two methods. So one is the cold process liquid soap making, and another is the hot process liquid soap making. And also there is a dual lye method of making liquid soap. So where we use both sodium hydroxide and potassium hydroxide to make the liquid soap. So why we use sodium hydroxide to make liquid soap is because it will accelerate the trace formation. So we will see why we are concerned about potassium hydroxide not able to trace immediately like sodium hydroxide in the further slides. Okay, then we will use something called as soap paste. So the soap that we get from making by mixing the oils with potassium hydroxide is that we will not get a solid bar soap like how you used to get in CP and HP method, which we have learned previously. We will get a very soft looking paste. Like how initially when you make the hot process soap, it will go through the Vaseline stage, right? And how soft that soap will be. Exactly like that, your final soap will be for a liquid soap. Okay, so that soap is actually called as a soap paste, and it is very very soft. That is why we need to dilute this. That soap paste will be like 100% soap paste. Okay, so we don't take that soap paste directly and start applying on our body. We need to dilute that soap paste into a form which is suitable for us. Like there are different ways to dilute the soap. Some people will say like 1:1 ratio you will dilute. Some will go even for higher dilutions or lesser dilutions. So regarding soap dilutions and how to calculate that I will teach you in the next in the, I think, the third class after learning how to make the liquid soap. Okay, because first you learn how to make, and then calculations and other things that you can easily learn, so that will not be difficult. But yeah, you need to concentrate on how to dilute the liquid soap. There is certain calculations for that. So that I will be teaching you in coming classes. So that is what we meant by soap dilution. So whatever soap we are getting, we need to dilute it into a suitable form so that we can use it as a liquid soap. Okay, that soap that we dilute may not be usually like very thick. It will be very very thin, especially if you're using only potassium hydroxide and you have used lot of coconut oil. Means because coconut oil has lot of lauric content in it, it is very very cleansing. You will get super duper bubbles in that 100% coconut oil soap. But your soap paste after dilution will be very very thin, even thinner than water. You know that viscous thing you will not get in coconut oil soap. So we can thicken those soaps using some thickeners. So the basic thickener we will use is salt. But some say they use other thickeners. Like in foreign, there is something called as Scrotix, which is available. I will find out the. I will type the in C. 1 minute. Scrotix. So. Even, yeah, Purenso has Scrotix available with it. Okay, so it is PEG 150 pentaerythritryl tetrastearate. So that also people use to thicken their liquid soaps. But I have not used Scrotix. I have also not used salt till now to thicken my soap. So I just kept it thin only. My liquid soaps are very, very thin only. But for the class, let me try to make to thicken with salt solution and see. Then there are some people also use gums, natural gums like hydroxyethyl cellulose, that also they use. But I have not tried, so I cannot talk about how it will work. Okay. And next we will see the major difference between sodium hydroxide and potassium hydroxide. So sodium hydroxide will always give you a solid soap, and potassium hydroxide will give you a soft soap. And the major difference, the chemical structure of sodium hydroxide and potassium hydroxide is different. So the molecular size of sodium hydroxide is very big, whereas that of potassium hydroxide is very very small. That is why it blends very easily with the oil, and it can actually clean much better than sodium hydroxide. And sodium hydroxide, when you mix it with water, we all know they are extremely exothermic, so they will give out lot of heat. But potassium hydroxide is also exothermic, but it doesn't give out the same heat as how you get with sodium hydroxide. Also, when you mix potassium hydroxide in water, they will make some fizzing or popping noises. So don't get scared when you are mixing the potassium hydroxide in water. It is that is how they behave when it is exposed to the water. As I already told, your potassium hydroxide is not 100% pure, so they will have some impurities. So that is the reason why like they have these different sounds. So the sodium hydroxide which we get is actually 100% pure. So that is why it is very, very caustic. Both are actually if you say in chemistry terms, both are actually bases. Okay, they are what we can say, they are strong bases only. Okay, you have something called as a strong base and you have something called as a weak base. So base means in chemistry it is alkali. Okay, so what I'm trying to say is both sodium hydroxide and potassium hydroxide are strong alkalis. So but they behave, their behavior is slightly different. Okay, sodium hydroxide behaves more like we can say like furiously, and the potassium hydroxide slowly mellowed down, little mellowed down behavior with oils, we can say. Okay, and another major difference, we will always get potassium hydroxide with impurities only. It is not available. The commercially available potassium hydroxide is never 100% pure, but sodium hydroxide is always 100% pure. And the manufacturing method of making sodium hydroxide is very, very cheap and easy because it is made from table salt only. Sodium chloride that they use to it undergoes hydrolysis to give you sodium hydroxide. But potassium hydroxide, the manufacturing cost is little higher compared to sodium hydroxide. Okay, so that is why if you buy the potassium hydroxide pellets, it might be expensive compared to your sodium hydroxide. Okay, now we will further learn about the chemistry or the function and the nature of how potassium hydroxide is. So potassium hydroxide, also known as caustic potash, it is a strong alkali, as I already told in the difference, like sodium hydroxide, and it is highly corrosive, meaning like when you put the drop of the lye solution of potassium hydroxide lye solution on your skin, when it touches your skin, it is immediately going to give you burns similar to sodium hydroxide. So you need to handle it very carefully, just like how you handle sodium hydroxide. And another important property of potassium hydroxide, it is highly hygroscopic, meaning it easily attracts moisture to itself, and it will become very liquid and mushy when it is exposed to air. That is why you need to keep it in a proper container which is very airtight, and you should not expose it to air that easily. Okay, and there were different methods how potassium hydroxide was initially made in the earlier times. So in early days, they used to make them using wood ash. So they used to burn the wood, and the ash collected from the woods, they used to treat it further, and that is how they used to get like a crude form of potassium hydroxide. Then with further advances in the chemistry, they use this method, like potassium carbonate and calcium hydroxide was used to make potassium hydroxide, but then still it was not very feasible, and the costing was very high in this method also. But now in the modern method, how we make is using electrolysis of potassium chloride. So potassium chloride with water, we mix it, and then we pass electric current through it, and then the chlorine gas will be released, and then we will get the potassium hydroxide, so that we will collect it from that. So that is how we are getting the potassium hydroxide that is made commercially nowadays. Why we need to use potassium hydroxide? Apart from soap making, it has other important uses as well. So it is also used in manufacturing dyes, like some dyes, the dyes which they use for coloring our clothes and fabrics and all. They require the addition of potassium hydroxide to it, so that they will produce the dye better, and they will maybe fix up the dye better in the fabrics. Then in batteries, those lithium batteries that you get, in that also, or I think these are car batteries, they use potassium hydroxide because they are better, they pass their, they are better conductor of electricity, so that is why they use potassium hydroxide. And also in the making of fertilizers, so you know that plants need a lot of potassium, nitrogen for their growth. So to make the fertilizer, we use potassium hydroxide as one of the component. So then, of course, for making soaps, we use potassium hydroxide. Okay. Next, we will see how the saponification in liquid soaps happen. Okay, so this is your triglyceride molecule. That is, triglyceride here refers to the fatty acids or the lipids. It can be any lipid, like you have your 8 major lipids that we are using in our soap making: lauric, myristic, palmitic, stearic, oleic, resinolic, linoleic, and linolenic. So all these, it can be any of these 8 fatty acids. So they exist, these fatty acids, they always exist as a triglyceride. Okay, meaning they combine with a glycerin molecule. Okay, and 3 molecules of them combine. Okay, so this is, this is one chain. Actually, there will be more like this, then one more like this, like that. Three chains of fatty acids and a glycerin molecule combine to form this triglyceride. So when this triglyceride reacts with potassium hydroxide, you will get glycerin will be released, plus you will get your soap. It forms a salt. So that salt, usually in case of sodium hydroxide, it will be a solid form. But in case of liquid, in case of potassium hydroxide, it will be very soft. It will not form a solid crystal structure. The crystal structure will be very fluid, we can say. Yeah. So next we will see about the lipids and superfatting in liquid soap. Okay, so unlike when you're selecting lipids for solid soap making, you will choose your saturated and unsaturated superfats. Usually you will keep your saturated superfatting, not superfat, saturated oils in the 40% category and unsaturated as 60%. So that way you will get a good, nice hard bar of soap, which is not very over cleansing, and it is mild and gentle and all that. But in liquid soap, you don't have like a hard liquid soap or a soft liquid soap. So there is nothing like that. So you don't have to follow the 40-60 rule here in liquid soap. And you can also, that's what I told, you can also make only with the soft oils also. So the best example, the best commercially made even till day today is the Dr. Bonner's Castile soap, So that is made using only olive oil and potassium hydroxide. Plus, they also include some other ingredients also to it. I don't know whether they are really including them or just for label claims they are adding them at 1%. So I am not very sure of that. So yeah, but actually cast iron soap means making the liquid soap entirely out of olive oil only, 100% olive oil with the potassium hydroxide. Okay. And when you are calculating the liquid soaps, so usually we will need to know their SAP value, that is the saponification value of each oil with the lye. Here the lye here is potassium hydroxide. So we have in our saponification chart, we also have the saponification value for potassium hydroxide as well. So each oils, I have only listed down few of them, but all the oils, whatever is available commercially, for everything we have the saponification value. Like for sunflower, it is in this range 189 to 195. For coconut oil, it is 248 to 265. So what does saponification value means? How much, like how much gram of how much amount of potassium hydroxide is required to saponify 1 gram of oil or fat. So that this is how you will calculate the saponification value. So the weight of potassium hydroxide divided by the weight of fat or oil into 1000 will give you the saponification value. And then when it comes to superfatting your liquid soaps, you don't superfat your liquid soaps as how you do your cold process or hot process soap, because we need to minimize the cloudiness, and we need all our oils, whatever oils that we are adding, both in the form of fragrances and essential oil, plus our soap making oils, everything, we want them to be completely saponified by the potassium hydroxide. We don't want any free floating oils in our liquid soap. If there are free floating oils in our liquid soap, the soap that we make, the liquid soap, after diluting the soap paste, we will not get a very clear liquid. We will have some cloudiness in it. It will be very hazy, or it will sometimes be milky. So we don't want that in our liquid soap. We want it to be as clear as possible. So we will always superfat them at maximum is 3%. Start from 1 to 2%. Okay. Then we will see what all the additives, colors, and fragrances that we can use in our liquid soaps. Like how we normally do for solid soaps, we don't usually add, like I have not personally added goat milk, fruit purees or vegetable purees. But what I have tried adding charcoal works well. I even tried to add clays, but the clays were not giving me, like I thought they will color my liquid, the soap paste naturally, but they didn't color much, and I was not very happy with how I got. So I don't usually recommend clays also. What I can recommend is, you can infuse the herbs, whatever herbal powders that you are having, into the oils first. Infuse them, either cold infusion or hot infusion, and then filter all the herbs. Okay, that the oil should only have their infused properties in them. Like they should not have they should not be having those bits pieces of those dried herbs or botanicals, because they will first they might cause spoilage when you do a soap dilution with them, and there are high chances of not getting a clear soap. Also, if you had too much of those botanicals or herbs in the oils and you don't filter them and you still make the soap, all those bits and pieces of those herbs or powders will try to settle at the bottom once you make your soap dilution. So I don't advise adding soap powder. The whole powders, the herbal powders or the botanicals directly in your oils and mixing up with the lye. Rather, you can infuse them, strain it, and then you can make your soap. So that will work perfectly. Other common additives that you can use in liquid soaps is glycerin. So it has a multi-purpose why we are using glycerin. So one is it is a good humectant and it helps to trace faster and also thicken our liquid soaps a little bit, and it gives us clarity. That is, when we make the soap dilution, the soaps that we get will be little bit clearer. Okay, and it also makes our liquid soap very stable. So the usage rate for glycerin is up to 20 to 40% of total oil concentration. You can use glycerin. Then other additives which we can use is sodium lactate. It will help to thicken, and also it gives clarity to our liquid soaps. Sugar, like I already told, even in the solid soaps, sugar will improve the lather. So same it does even in the liquid soaps, it improves the lather. Then salt, we will use to thicken the soap after dilution. So once our soaps is made, the soap will be very very thin. So if we prepare a brine solution, and brine solution means like you add 50 percentage salt to 50 percentage water, and you make a solution of it, 50-50 solution, and then you add in 1 gram or 2 gram increments. You keep adding the the brine solution to your soap that you have made, soap paste, that soap dilution that you have made. Then slowly you can notice it will start to thicken. So that we can use salt, we can use. Then colors, always I recommend to use liquid colors or water based colors are suitable here. I tried to use natural colorants like Manjishta, but it did not give me very good result. So I don't suggest to use any natural colorants. Go for any whatever is synthetically available. Micas you cannot use to color the liquid soap because the mica particles are little heavy, so they will settle at the bottom, and they will not be uniformly suspended in the liquid soap. So that is why we don't use micas for coloring them. Then fragrances, you can use both essential oil or soap fragrances. But first you need to check how each essential oil or the fragrances behave with your soap dilution. Like once you made your liquid soap, how it behaves, you need to test each fragrance and essential oils to see how it behaves, and then you can use them along with a solubilizer. So some of the solubilizers I have listed here, they are polysorbate 20, PEG 40 castor oil, and then these are PEG 20, PEG 40 and polysorbate 20 are not natural solubilizer. They are synthetic, and they don't go well with the natural category of these people who are more into the natural soap making category, or only with the natural ingredients category. So they are not natural. Polysorbate 20 and PEG 40 castor oil, they are not in the natural category. So other natural categories, you have the Sepiclear and Capril glucoside. So those you can use as a solubilizer. Even Olivem 300, if you have, you can use for solubilizing your fragrance and essential oil. So the usage of solubilizer also will differ according to your essential oil and fragrance. You have to see trial and error how it is working for you, and then you can use to make it into your bigger batch first you test a small batch of the fragrances, how it behaves, and then you can go in for the bigger batch. Okay. So next, yeah, we will see about this types of liquid soap making. I told, right? Cold process, hot process, and UL lye method. So in cold process, what we will do is, so we will weigh our oils and lye separately in containers, and then we will allow the lye solution to cool down. And then to this cooled lye solution, we will add our sodium lactate. Okay, that is one of the additives which we will add. And then once the lye and the oil is cooled and it is at 30 to 540 degrees, we will start our soap making process. So, and also we try to sieve, when we, before adding the lye solution to our oil, we will sieve our lye solution in case if there are any impurities. Like I told, no, potassium hydroxide is not 100% pure. So they will have some impurities even though you mix it with a distilled water. So that you can remove by using a sieve. Okay, a fine mesh sieve, so that any impurities will not be added to your melted oils. So once you mix your oil and lye solution, you need to stick blend them. So the stick blending, you need to like blend them for a very, very long time compared to your sodium hydroxide, because the potassium hydroxide soaps take very, very long time to reach trace. So by trace, it's not like the trace you can see in your sodium hydroxide, you know, the thick trace, and it will be nice, and like, you know, it almost starting to solidify. Here in liquid soap, no matter how much you know, blend, it doesn't even thicken up like how it does in solid soaps. So it will thicken up like this in this picture, how it is there. So that it will thicken up, but you need to make sure. Again, what happens when you do a cold process method is like you blend and keep it, and then what you do, you cover it. We cover it with a cling wrap, and then you wait for some time, like you wait for 15 minutes once you check, or 30 minutes once you check. You just see if they are separating, because like how sodium hydroxide, once you add it to the oil and you start to blend it, like even if you give a short burst, it's enough for it to like immediately start reacting, and it will convert into, it will start to saponify. This potassium hydroxide, what it does, you know, when as soon as it meets the oil, it will blend, but it will actually look like it is separating again. You can see the oil and the lye will separate. So that is the reason why once, even though it reaches this particular trace, it is not actually a true trace. So you have to keep blending like this, covering and checking if it is separating, then blending it. So like that you need to do two, 3 times, so that properly it blends. And then you just once you have made sure, okay, it is no longer separating and it has blended nicely, you cover it and just leave it overnight. Okay, and the next day when you see your container, you will have this like a gel kind of a paste, just like how you had it in your hot process. No, it will be that Vaseline stage. So exactly like that, when that stage is reached, the next day itself it will come. So you take a small container of water, again distilled water, and you, like say for example, you are adding 10 grams of, you're having a container of 10 grams of water. To the 10 grams you add like 1 gram of the soap paste or 2 gram of the soap paste, and you mix and see, and you check the clarity. By clarity I mean how clear your container is it having any cloudiness, is it having any any is it very milky looking or how it is looking. So if it is very clear means that means your soap is done. I mean, it has saponified. So that is your soap paste. Now, after you have your soap paste, you will need to add distilled water. So how much distilled water you will add, that you should do, you should calculate by, there are some few methods how to calculate the water for diluting your soap paste. So once you calculate that, you will add that much amount of water to that soap paste, and you will again leave it, allow it to slowly dissolve itself, and it will dissolve, and then you will be left with a completely clear liquid soap. So that is how you make it by using a cold process method. Okay. So for hot process, it is slightly different, meaning you will heat up. So you will heat your oils, and your lye solution also will be hot only. So you will allow the lye solution to cool down to 90 to 110 degrees Celsius. So that much temperature you will maintain. And then you will use a double boiler or a crock pot and maintain a temperature of 70 to 80 degrees Celsius in that. And then you will continue to blend and blend your oil and lye mixture and bring it to trace. It will go through various stages. So first it will become like a white pudding, and then it will become very fluffy like this, and then you will continue to cook it, and then it will reach this mashed potato stage, and then it will become a translucent gel. Okay. Then after it reaches the translucent stage, you will check for clarity. If it is not, the solution is still very cloudy, you will cook for some more time till it becomes clear. And then once it is clear, you will that will be your soap paste, and you will dilute it by the dilution method. Okay, how much ever like for the soap paste, how much you have prepared, how much dilution is required, you will add that much amount of hot water you can add. So it will become faster, the dilution will become faster, and you will get your liquid paste also faster. Okay. Otherwise, if you don't want to dilute it immediately, what you can do, you can store your soap paste in a Ziploc container, in a Ziploc bag or in an airtight container. They will last you for months, or even I have kept for years also. So nothing has happened. There's no problem with my soap paste till now. So like they will go on forever, just like your solid soaps. And then we have our dual lye method. So here, we will follow the same procedure of how to make a cold process or a hot process. Only thing we are using is we are also adding sodium hydroxide apart from our potassium hydroxide. But the sodium hydroxide we are adding will be in very less percentage. So either we can go for 10% sodium hydroxide or 20%. Okay, so this is the range. So you can even go for 15% sodium hydroxide. So it's up to you. So if you use 15% of your sodium hydroxide, so 85% will be your potassium hydroxide. Okay, so the ratio will be like that. There are calculators for calculating this dual lye soap. So I will share that with you. So this is the calculator. I have just posted a picture from the calculator that I have calculated. So this one I have calculated using SaponiCal. So you can use any of these three calculators: Soapy.com, Soap Making Friend, and SaponiCal. They all have the dual lye part in them, so it will be easier for you. And also they have this option of the purity of your KOH. With the soap calc that we usually use, it only displays 90 percentage potassium hydroxide. It doesn't display other, it doesn't allow us to change the purity of our potassium hydroxide. But the potassium hydroxide that I have and that I was able to find was only 85 percentage pure. So I cannot use the same 90 percentage pure KOH calculator. So it will give me a wrong calculation. So that is why I chose these three calculators. Either you can use soapy.com, Soap Making Friend, or Saponical. Guys, are you following me, or should I stop somewhere and explain you again? Let me know.
No, it's fine.
Okay. So yeah, so this one I have taken from Saponi Calc. I will also show you like how the Saponi Calc will look. I'll share another screen. 1 second. Okay, so this is how the Saponi Calc will look in online. So you will have your soap type, bar, liquid, hybrid, and then your super fatting will be here. Oil weight we need to change. We can choose even 150 gram or how much of a gram. So here is where our KOH purity comes. So when you select liquid soap, you will need to select your KOH purity. So the one which I have, and my KOH purity is 85%. So I have chosen 85%. Usually in most of the soap calculators, it will be 90. So sometimes they will be fixed, like the Saponi Calc has it fixed to only 90% purity. But I don't have 90% pure potassium hydroxide with me. It's 85%. So I will change it to 85. Okay, and then I will add my super fatting. So up to 3% I can add. I'm adding 2% super fat. And then oil weight, I can write it 150 gram, or for your I have included 250 gram. Let me know you want to do a 250 gram or a very small batch. I think 150 gram also will give you because 250 gram, by the time you get your soap paste, the weight of the soap paste comes up to 450 gram. So that is like too much of liquid soaps that you will be having. So I will change it to 150 gram. And our lye concentration, we will keep at 33. Even we can do a 35%, 35 or 36 also we can do. Okay, we will keep at 33 so that we won't disturb. Fragrance, we will add at 30%, 30 grams per kg. Then oils we can select. So these are the oils that I have selected: castor oil, coconut oil, sunflower oil, and shea butter. So castor oil I have chosen 10%, coconut oil 30%, sunflower oil I have chosen 50%, and shea butter 10%. Now after selecting all of this, I will just put calculate. Okay, it will calculate and give me everything. So we will choose, we need to take 73.25 grams of water. Potassium hydroxide we need to measure is 36 grams. Castor oil 15 grams. Coconut oil 45 grams. Sunflower oil 75 grams. Shea butter 15 grams. And all this we need to measure, and our soap weight will come up to 263 grams. Okay, and we will be adding certain additives, right? So additives also I have added. So sodium lactate, once you make your potassium hydroxide solution, you can add 3% sodium lactate. So that will be I changed it, right? So I changed to 150 grams, right? So I will calculate. I had calculated and kept for 250 grams. So for 150 gram, it will be 3 divided by 100 into 150, which is 4.5 gram. And sugar also will be 5%. So that will be 5 divided by 100 into 150. So 150 is my total oil concentration. So it will be 7.5 gram. In the slide that I have shared, I would have made for 250 gram of the liquid soaps, but you can even do lesser. Okay. We will do 150 gram itself. So this will be our soap that we will be making. Let me share the screen again. So that is what I have just placed the pictures of all this. So you will first you will need to select the soap type, super fatting, oil weight. You will check your water, then fragrances. Then you will select the oils, and then you will give calculate. It will calculate your soap everything and give you like how much weight you need to take for each oil. Yeah.
So I'm not able to see the full screen shared by you.
Which one? Now you're not able to see my screen?
Only basic liquid spelling is also half liquid. But the screen is
Okay, I will stop
not
sharing and I will share again. Now you are able to see the whole screen?
no.
No.
Only the basic
I can see,
like
no
you.
problem.
Yes.
Otherwise, you rejoin again, no? I will share the basic liquid soap recipe. I will post it in the group today. So we will be making this soap in our next class. That is on Thursday. We will be making this soap. We will be doing a cold process method first. Okay. And then in hot process, I will try to make the dual lye. And I will make using charcoal soap we will make, charcoal liquid soap we will make. And one is this goat milk. I have personally not made on me, but I'm little hesitant to use goat milk because the milk will have certain fat in it and I need to add extra lye. I still haven't figured out how much to add that extra lye and how to calculate that part. So once I myself will be thorough with that, then I'll teach you guys. So that is, and when you make it using milk or other products that have extra fat in them, you need to even account for that fat in your calculating your liquid soap, because as I told it, these fat will really affect your clarity of your soap. So if you don't mind your soap to be cloudy or anything like that, then you can go ahead with making milks, adding any kind of milk to your soap. But if you um, if you want a really clear soap, then yeah, you need to account for the extra milk in it and the fat also in it. So you need to add, it will be little lye heavy. So I still haven't learned myself how to do that, so I cannot teach you that. We will go for the basic ones. I can like show you infusions. I have done charcoal, that has worked out well for me. I have tried a natural colorant using Manjishta, but the color was not very, like, it was not looking good on me. I'll show you the soap paste. It's not very good looking. Then I tried using green clay. So green clay also didn't work out well for me. So that's why I thought, okay, better not to go for any of these. Rather, maybe, yeah, we can do infusions. Like you can infuse all the powders in your oils and then filter them, and then you can mix it with the lye and you can use that liquid soap. But yeah, so these much only I have learned myself in the liquid soap. I have not further, like, experimented much in liquid soap because I was more interested into I wanted to learn soap making, so I started slowly experimenting with liquid soaps and cream soaps and all that. But somewhere down the line, I lost interest. No one is making anyways liquid soap, and this liquid soap you can only use for your like body and face and all that. Even though, but the pH will be a little high, like how the solid soaps are, and you cannot use them as your shampoo and all that, because this lye alkaline soap, it makes your hair little say uh, gloopy, or it's not nice thing for your hair. Like have this surfactant based shampoos that we are taking and using conditioners for that. Any that matter, be it soap, liquid soap, don't apply it on your hair. They don't well for your hair. Your hair does not like them, and people do use them and they claim it's very good, and they sell even shampoo bars. As long as they are based and it's not alkaline ones, or the one made with oil and lye are not good for your hair. I don't recommend them for your hair. Okay, so yeah. Now, who was the one who was saying like you were not see my screen? Now you're able to see my screen. Let me know.
No, not now.
You're able to see my screen, right?
It's only 1.3.
No, I'm not able to hear.
You share the pictures in the group. I think there is a problem from my side.
Okay. It's still not updated in my. Let me check.
So you're telling those that shampoo bars are not good. I mean, whatever
No,
is.
shampoo bars, I'm saying, as long as they are made with surfactants. Surfactants like sodium cocoyl isothianate, like those kind of ones, not made using oil and lye. If you see in their ingredient list, if they are made using oil and lye, those kind of shampoo bars or liquid shampoos, I will not recommend them for using on your hair, because they are highly alkaline. Okay, and our hair is not a alkaline favorite thing. It prefers acidic. Maybe it can tolerate acidic but not alkaline, definitely. So they become very I mean, it does for me actually. It becomes very very oily and it's very dull looking. It's not a very good feeling for the hair. It's very heavy for me. um, the hair strands are not nice and soft as how you get it with the regular surfactant based ones. So that is why I personally don't recommend a oil and lye made soaps. Okay, so soaps, they are synthets. We call the commercially available shampoos or shampoo bars as synthets. Okay, so synthetic detergents, short form of that. Okay, if it is made using synthetic detergents, yes, definitely you can use for your hair, but no, even on your body also you can use these synthetic detergents, but you don't use these liquid soaps and solid soaps as shampoo bars on your hair. That is what I was saying. Okay, so we will do this basic liquid soap on Thursday. And then, yeah, further topic is troubleshooting in liquid soap. So major issue which we will face in our liquid soap is cloudy soap. So why does the soap become cloudy? There could be many reasons for this. So one is we have used tap water for making our soap, be it a soap dilution or for making your soap, always use distilled water or deionized water. Then otherwise, what could be the other reason is there is some unsaponified soap in our soap mixture that we have made. So meaning to say the lye is not enough for the oils we have, or it is maybe less lye in our soap that we have made. So we need to account for that. So that is the reason why our soap is cloudy. Or else sometimes what can happen is fragrances. When you add certain fragrances, be it essential oil or the fragrances, it can cause cloudiness. So that is also one of the reason why our soap is cloudy. Another reason is there will be some oils floating on the top. Like it, once you dilute your soap paste, still there is a thin film of oil in your diluted soap paste. That can be due to the fragrances you have added. You have not solubilized it. You have just directly added your fragrances or essential oil to your diluted soap paste, and that is the reason they will float on top. Like they will not mix up with your liquid soaps. So you always need to use a solubilizer when you're using the fragrances, uh, be it essential oil or fragrances, both of them. Then they are temperature sensitive. That is, once you make your liquid soaps, in India, you don't have to bother about it, especially in the south. If you are living, the temperature is very, very warm here throughout the year. So, but in very cold places, like abroad and all that, where they go for minus degrees. So there, definitely your soaps, that is your liquid soaps, might start to thicken up when it is very cold. So once it reaches your normal uh, 30 degrees or 25 degrees, no, not even 25, I think, 18 degrees also should be fine. Yeah, that will not be so cold. So then your soap liquid, that is your liquid soap, will not start to solidify or start thick, like how your coconut oil and all behaves, in very cold climate. So the same thing happens even with liquid soap. Then milky soap, the soap appears very milky. That is due to unsaponified oils. Then skin irritation, like when you apply the liquid soap on your skin and it starts to itch, then maybe your soap is lye heavy. So that is the reason why you have skin irritation. So these are the common troubleshoots that you will get with liquid soaps. And then that's it. With that, we are finishing our theory and we will be doing our practicals in our next class. So I have personally not done much experiments with liquid soaps. I have done very limited experiments. So whatever I have experimented, I have shared that my experiences with you all. So maybe if I get to have further experience myself using goat milk and other milk in liquid soaps, I'll definitely share with you guys.
Okay.
So till now, for tomorrow's class, that is on Thursday's class, we will be doing just a basic liquid soap. And then on the next class, that is on next Tuesday, we will be, I'll try to do a dual lye with the charcoal. Okay. And yeah. So, and then I will teach you how to do the calculation part of it on the next class. So I have posted the schedule for this month. So we will be following that schedule only. And also I will try to post the supplier for this potassium hydroxide, the laboratory grade potassium hydroxide. Okay. So I will post them in the group today. Any other questions you can ask me?
No, that's it. I was for a hot process soap. I just wanted to know
Hmm.
this sodium lactate and that yogurt and all. No, that
Yeah.
you can add in any order, or you have to follow the exact order in the video.
The solid soaps you're telling, right?
Yeah, for HP.
Yeah, you can add it. See the sodium lactate. Yeah, you can add it even with yogurt also. That will not be an issue. In case you forget it when you are making your lye solution, you can add it with yogurt also. It's nothing like that. You have to follow only that way. Nothing like that.
Okay. So after the mashed potato stage,
Yeah.
you can start adding them.
Yes. Even your sugar solution, you forgot to put sugar in your lye solution. You can add it now when you're adding the yogurt. So all these yogurt and the sugar solution, all no, will try to make your batter loose. So that way, we want our batter to be very fluid, no? So that we can pour it into mold and we can do minimal designs in it. So that is the reason.
Okay, thank you. That's it, right, for the today?
Yeah,
Okay, thank
today's-
you. Bye.
yeah, thank you. Bye.